The incremental snapshot merging subsystem provides a mechanism for combining multiple delta files into a consolidated base state without requiring full materialization of intermediate states. The system maintains a merge queue, which is processed sequentially according to age and size heuristics. Base snapshots are stored in a dedicated tier, separate from transient delta records. The merge process respects isolation semantics, ensuring that concurrent read operations continue against the current active snapshot. Delta computation begins with a scan of all modification records since the last successful merge point. The system records the timestamp, operation type, affected record identifier, and checksum for each delta entry. These records are organized into batches corresponding to logical partitions within the data store. Batch boundaries are determined by a configurable size threshold, with a default value of 16 megabytes. Overflow conditions are handled by splitting batches at partition boundaries. The reconciliation phase identifies conflicting modifications across delta batches. A conflict occurs when two deltas affect the same record within a single partition. The conflict resolution strategy is determined by the reconciliation policy parameter, which supports last write wins and application-defined custom handlers. When last write wins is configured, the system preserves the delta with the highest timestamp. Application handlers receive a conflict descriptor containing both delta values and must return a single reconciled value. Merge eligibility is determined by a cost function that evaluates the number of delta files, total size, and age of the oldest delta record. The eligibility check runs periodically according to the merge check interval setting, which defaults to 5 minutes. When the accumulated delta size exceeds the merge size threshold, or when the merge age threshold is surpassed, a merge operation is automatically scheduled. Manual merge requests bypass these heuristics and proceed immediately. The merge worker thread reads all eligible delta batches sequentially from persistent storage. Each batch is decompressed using the codec specified in its metadata header. Decompression failures are logged and trigger a fallback recovery procedure that rereads the delta batch with alternate codec configurations. Successfully decompressed batches are held in the merge buffer, which is allocated from the general memory pool and released upon merge completion. State reconciliation operates in 2 phases. The first phase performs record-level deduplication by sorting all deltas by record identifier and partition. Duplicate deltas for the same record are consolidated according to the active reconciliation policy. The second phase applies conflict resolution handlers if applicable. The reconcile state is maintained in a temporary merge accumulator structure that grows linearly with the number of reconciled records. Checksum validation occurs at multiple points during the merge process. Deltas within each batch include per-record checksums using the CRC32 algorithm. When deltas are consolidated, the system computes a new checksum for the reconciled record. Batch-level checksums are computed as cumulative XOR of all record checksums within that batch. Mismatches trigger a merge checksum failure event and prevent the merge from proceeding. The merge accumulator periodically flushes its contents to intermediate snapshot files as a safeguard against memory exhaustion. Flush operations are triggered when the accumulator size exceeds the flush threshold, which defaults to 64 megabytes. Each flush writes the current reconcile state to a temporary file with the naming convention of merge temp merge id flush sequence.snap. These temporary files are tracked in a metadata journal for recovery purposes. Isolation is maintained during merge operations through the use of a read-consistent snapshot handle. Active merge operations acquire a shared lock on the current base snapshot, preventing its replacement. Read operations continue against the locked snapshot while the merge worker constructs the new merged state independently. Once merge completion is validated, the new merged snapshot is atomically promoted to the current state, and the lock is released. Delta tree organization follows a hierarchical structure, where level 0 contains raw delta batches, and level 1 contains partially merged states. Advanced merge strategies allow constructing intermediate merge trees to reduce memory consumption for very large merge operations. The tree depth parameter controls the maximum number of merge levels. The default tree depth is 2 levels, which accommodates typical merge operation sizes without requiring excessive intermediate storage. Merge completion validation includes a full pass through the merged snapshot data verifying record integrity and checksum consistency. If validation fails, the merge operation is aborted and the previous base snapshot remains active. Delta batches that failed merge are retained for retry. The system logs a merge validation failure event and optionally triggers an administrator alert if consecutive merge failures exceed the max consecutive failures threshold. Archive management handles the retention of old Delta batches and superseded base snapshots. Once a new merged snapshot becomes active, the deltas that contributed to it are marked for archival. The archival retention days parameter specifies how long archived materials remain accessible for recovery. Default retention is 30 days. After the retention period, archived files are removed from the system, freeing disk space allocated to the snapshot subsystem. Performance metrics are collected throughout the merge lifecycle. The system tracks merge duration (ms), which measures wall-clock time from start to completion. Delta bytes processed counts the total input size. Merged bytes written counts the output snapshot size. Conflict count records the number of reconciliation operations performed. These metrics are aggregated into hourly and daily summaries and exposed through the metrics collection interface for monitoring and alerting. The merge min age threshold parameter prevents frequent merging of recently created deltas. This threshold defaults to 1 hour, ensuring that hot data is not immediately consolidated. The threshold interacts with merge size threshold such that whichever condition is satisfied first triggers the merge eligibility check. Customizing these parameters requires understanding workload patterns and storage constraints. Conservative values reduce merge frequency but may increase memory usage. Recovery after merge interruption is handled by the merge journal, which records the state of all in-flight merge operations. If the system restarts during an active merge, the journal is consulted to determine whether the merge state can be recovered or if a fresh merge must be initiated. The recovery mode setting determines behavior. Automatic recovery attempts to resume partial merges, while conservative mode discards partial state and restarts from the last stable base snapshot. Configuration tuning for snapshot merging should be informed by monitoring observed merge, duration, and delta accumulation patterns. Systems with high write rates benefit from lower merge size threshold values to keep merged snapshots current. Systems with periodic write patterns may use higher thresholds to batch more changes together. The merge parallelism parameter allows multiple disjoint merge operations on different partitions to proceed concurrently, but this requires proportional increases to merge buffer max size.